Okay, let's get started here with solving systems of equations graphically. So the first thing, like we've started many of these lessons in this chapter, is let's think about what do we mean when we say solution. Okay, so here in this first example we have 2y equals 4x, and the question is, how do we represent the solutions to this two variable equation? Well, you think about real quick, there's a few solutions that might come to mind first. So like 0, 0 is a solution. You plug in 0 and you get 0. Another one would be like 1 for x and then 2 for y. That's another one. And there's a lot of these, and they're not all integers, right? So the question is, how do you represent that? Well, the way that we represent all of the x and y values that make that equation true was using a line, okay? And the line, this line would have a slope of, if we solve this for y, this would be y equals 2x. So this would have a slope of 2 and a y-intercept of 0. So this is what our line would look like. Okay, so that's all of that line covers all of the solutions that make that equation true. If we jump over here to the right, let's look at what the solution to a system of equations would mean. In other words, what are the x and y values that make not only this equation true, but also this equation, okay? And so we can approach that with this kind of thinking. If a line represents all of the solutions to this equation, then we could make another line that represents all the solutions to this equation. And if they ever crossed, that would be the x and y values that make each one of them true. Okay, so let's look at the graph, and let's use a different color here just for fun. So we'll go blue here. All right, so the first one we already graphed was 2x, and it looks something like this. Okay. The other one has a slope of -1 and a y-intercept of 3. So let's go up 3, and then we'll go slope of -1. So down 1 and over 1. So that line will look like this. And so again, all of the solutions to the first equation by the first line there, all the solutions to the second line there, where do they cross? That will be the solution to the entire system. So it's right here. And that point is, what would it be? 1, 2. Okay, so our solution here is 1, 2. In other words, if you plug in 1 for x here and 2 for y there, you'll get a true statement. And if you do the same thing here and here, you will get a true statement. So 1, 2 is the solution to that system of equations, okay? Let's go on to another example here. So this is one way to solve them, is to graph each system, graph each equation, and find where they cross. Okay, so let's see, solve this system of equations. What I'd like to do here is I'd like to bring up a Desmos graph to show you how to do this. So if I think I already have it loaded here. Let's see. Let's see if we can put them next to each other. All right, so yeah, I do. So here is this system of equations, -2x plus 8 and 4x plus 7. And so you get the graphs, and you see over here that where they cross. That is going to be the solution to the system. Okay, so I'll make it a little bit bigger. And with Desmos, it's quite straightforward to figure out where that point is. You just click it, and it says right there that it's at 1.67, 7.67. So what you're going to write for your answer, I'm not sure if I said this yet. In Algebra 2, we're going to go to 2 decimal places, unless it tells us otherwise. Okay, so 2 decimal places. And so our solution, it's not nice, but it is a solution anyway. Where they cross is 0.17 and 7.67. Okay, and that's it. So to solve that system of equations, if we're using the graphing method, the graphing technique, we just graph each one, find where they cross. Okay, so let's hop back over to just the notes, and then we'll go on to the next one. Now the next one, the problem with this one is that it is not already in slope-intercept form. Number 1 was quite straightforward. We just had to plug them in. These ones are not in slope-intercept form, so we will have to be a little bit more careful here. So I guess that's as far as I can get it over to the side here. All right, so here's what we will do. We are going to get the first equation in slope-intercept form so we can easily graph it. Okay, so we'll go over here and do this. We've got 2x minus y equals -1. I'm going to move the 2x over to the left, so I get -y, or to the right, negative y equals negative 1 minus 2x. And then I'm going to times both sides by negative 1. Okay, so this will be y equals, so when I distribute the negative 1, I'll get 1 plus 2x. Okay, and so there's our first equation. And then we're going to come over here and get the other equation. So this one will be, let's see, so we've got 2y plus 5x equals negative 16. And then I'm going to minus the 5x over, so I'll get 2y equals negative 16 minus 5x. I'm going to divide both sides by 2. And so remember, when you divide when you divide multiple terms by a number, you divide it into each part, so you'll get y equals negative 8 minus 5 over 2x. Okay, so we're going to graph both of these, and we're going to find this, the intersection, and that'll be our solution. So when you, so I'm going to show you how to do that on the TI-83 Plus. So we'll cut to that clip real quick, and then we'll come back here in a second and talk about the rest of it, the notes. So what we'll do here is, in the y equals, we are going to put each equation. Okay, so I have negative 8 minus 5 over 2x, and then I have 1 plus 2x, right? And so what I'm going to do then is I'm going to hit the graph, and you can see the lines graph right there. And the intersection of those two lines is the solution. So how do we find that? Well, we're going to go second, calculate, and we want to find the intersection. So we use the intersect command, which is number 5. Hit enter. Now pay attention to this, because on lines it's pretty straightforward, but you want to know what's going on here for curves or sets of curves that are not just straight linear. All right, and so what it asks you first is it asks you for the first curve. Okay, so hit enter on that. That's the first line, and then it should automatically jump to the second line. Okay, so you can hit enter again. If it doesn't, you can use the up-down arrow keys to switch between curves. So if you have 3 curves, it may not jump to the one that you want, so, or 3 lines. You can arrow up and down to switch. If you can't see your cursor that well, like let's say that the cursor was right here, you don't really know where it is, left and right arrows move the cursor along the same line or the same curve without moving it around. So we hit enter again on this line, and then it says take a guess. Now there's only one intersection here, so the guess doesn't really matter that much, but if there was multiple intersections, like with different kinds of curves, you would need to be a little bit more careful with your guess. So hit enter again on the guess, and it will tell you that the intersection is at negative 2, negative 3, and that is the solution to that system of equations. All right, so hopefully you saw that the solution to that one that you got from the graphing calculator was negative 2, negative 3. And that's how you do it on the TI-83 Plus graphing calculator. So a couple ways that you can do that one. All right, now let's talk about possible solutions here. Possible ways that your solutions could look. So 3 types of solutions. We've already looked at one type. That is one solution. That's where you have a line and another line, and they cross at one point. But it's possible. Oh, and we call this system consistent and independent. That was a D. Consistent and independent. Okay. It's possible that there's no solution. So suppose that you had 2 lines that never crossed because they were parallel. Okay, so we call those systems inconsistent. Sorry, my penmanship is not great here. Inconsistent. And it's also possible that you have infinitely many solutions, and that's what would happen if you had one line and then you graphed another line and they happen to be right on top of each other. Okay, so in that situation we call that consistent and dependent. So 3 different ways that you can have solutions to systems of equations, or sometimes not a solution. All right, last one here. Let's look at this word problem. Alejandro has a computer support business. He estimates that the cost to run his business can be represented by cost equals 48x plus 500, where x is the number of customers. He also estimates that his income can be represented by income equals 65x minus 145, we want to know when he's going to break even. So what you need to do is you need to graph both of these lines and figure out where they cross, because hopefully at some point the cost will be less than the income. All right, so I'm going to show you how to do that on the graphing calculator, because doing it on the graphing calculator also means you have to get good at using the window in the graphing calculator, which is a skill that I'm going to try and show you. So you get the solution to that, and that'll be it for 1.6. So what we have here is we're trying to figure out when Alejandro is going to break even, okay? Because he's got a certain cost associated with each customer, and then a certain income that he gets from each number of customers. So how many customers does he need? Well, you can see that this is just going to be, that break-even point is just going to be wherever these lines intersect. Because if you look at, if you guys can see this or not, but we look at the problem here, this is a line, and you can see that at some point, hopefully his income is going to go above his costs. So let's look at these graphs. Now, when we graph these, we may not be able to see anything. Okay, so well, there's one line right there. Okay, but we can't see a lot of it because look at how big these numbers are. 500 and negative 145 for the y-intercepts, and the slopes are 48 and 65. Okay, those are pretty big. So what we're going to do is we're going to change the window. So we're going to go to the window, and we're going to tweak it. Now, some students like to use the zoom feature. I hate the zoom feature because it is like using a sledgehammer for all of your problems. Sometimes the sledgehammer is the perfect tool. Lots of times it is not the perfect tool, and you end up doing more damage than than help. Okay, so let's change the x's and y's here. Let's start with the y's, okay? Y maximum. Well, the y-intercept on 1 is 500. So we need to go to at least 500, but let's go even bigger than that. Let's go, I don't know, 5,000 maybe. Okay, we should be able to at least see it there. And then on the x's, we know that the slope in one of these is 48, the slope in the other one is 65. That means up 65 over 1. So, I don't know, maybe we put 50 on the x's just to try it. And you just kind of guess and check and see if you can get both lines in the window. This one gets us pretty close. We could even go a little bit further to the right. Maybe we go over to 100. Usually you want to err on the bigger side because if you go a little bit too big, you'll probably still see the important parts of the graph. So this intersection point is the break even. Right here, this top line is the cost. The bottom line is the income, and you can see that eventually income goes above the cost. So we need to figure out what that point is. We'll use second calc intersect to figure that out. Enter, 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 because it's just two lines and one intersection. And so we see that right here at about 37, so he'd need 38 customers to break even. So the answer on that one, I guess we can write it down here, is 38 customers. So yeah, right, customers. Okay, so 38 customers is the break-even point, and again, we did that by, we looked at the cost line, and we looked at the income line. Imagine these were like good lines right here. And so this point was at about 38, comma, 2321. Okay, the y value doesn't matter that much because we just want to know the number of customers. Okay, so that's how you do that problem.